I'm going to talk about the flip-flops. Well, first of all, there are digital circuits that are called conventional. It means that their output depends only and immediately on their inputs. What does this mean? Well, this means that they do not have memory or that they cannot store data. And then we have the sequential circuits. A sequential circuit acts as a storage element and have memory. This means that they can store information and use it when needed. To make this easier to understand, the storage elements are devices capable of storing binary information. The sequential circuit works in this way. They receive binary information from external inputs that, together with the present state of the storage element, determine the binary value of the outputs. There are two main types of sequential circuits, and their classification is a function of the timing of their signals. The circuits are synchronous and asynchronous. A synchronous sequential circuit is a system whose behavior can be defined from a knowledge of its signals at discrete instants of time. The behavior of an asynchronous sequential circuit depends upon the input signals at any instant of time and the order in which the inputs change. The storage of elements commonly used in asynchronous sequential circuits are time delay devices. And because of the feedback among the logic gates, an asynchronous sequential circuit may become unstable at times. So it means that the instability problem imposes many difficulties on the designer. On the other hand, a asynchronous sequential circuit employs signals that affect the storage element at only discrete instants of time. Synchronization is achieved by a time device called a clock generator, which provides a clock signal having the form of a periodic train of clock pulses. Here is an image of a clock signal. Synchronous sequential circuits that use clock pulses to control storage elements are called clocked sequential circuits and are the type most frequently encountered in practice. The storage of elements, or the memory, used in clock sequential circuits are called flip-flops. A flip-flop is a binary storage device capable of storing one bit of information. This means that the output of a flip-flop is either 0 or 1. A change in a state of the flip-flop is initiated only by a clock pulse transition. For example, when the value of the clock signal changes from 0 to 1. When a clock pulse is not active, the feedback loop between the value stored in the flip-flop and the value from the input to the flip-flop is effectively broken because the flip-flop outputs cannot change even if the outputs of the combinational circuits driving their inputs change in value. This is why the asynchronous circuits are sort of a problem to the designer. Storage elements that operate with signal levels are referred to as latches. Those controlled by a clock transitions are flip-flops. Latches are said to be level-sensitive devices. Flip-flops are edge-sensitive devices. The two types of storage elements are related because latches are the basic circuits from which all flip-flops are constructed. So now let's talk about the us-R latch or the us-R flip-flop. The us-R latch is a circuit with two cross-coupled NOR gates or two cross-coupled NAND gates and two input labeled S for set and R for reset. The latch has two useful states. When output Q is equal to 1 and Q1 is equal to 0, the latch is set to be the set state. When Q is equals to 0 and Q1 is equal to 1, it is in the reset state. Here is a picture of the us-R with non-logical gates and the behavior of the output. And here is another with non-logical gates and the behavior. So now let's talk about the D latch or the D flip-flop. Well, one way to eliminate the undesirable condition of the indeterminate state in the R latch is to ensure that the inputs R, S and R are never equal to 1 at the same time. This is done in the D latch. This latch has only two inputs, D for data and E for enable. The most economical and efficient flip-flop constructed in this manner is the edge trigger of D flip-flop because it requires the smallest number of gates. So here is an image of the D flip-flop and its behavior. So now let's talk about the other flip-flops. Other types of flip-flops can be constructed by using the D flip-flop and external logic. Two flip-flops less widely used in the design of digital systems are the JK and the T flip-flops. There are three operations that can be performed with a flip-flop: set it to 1, reset it to 0, or complete its output. With only a single input, the D flip-flop can set or reset the output, depending on the value of the D input immediately before the clock transition. So here is an image of the JK flip-flop and its graphical symbol. The toggle or the T flip-flop is a complementing flip-flop and can be obtained from a JK flip-flop when the inputs J and K are tied together. Here is an image of the T flip-flop and its graphic symbol. So now, some information of the graphic symbols. The dynamic indicator greater than denotes the fact that the flip-flop responds to the edge transition of the clock. A bubble inside the block adjacent to the dynamic indicator designates a negative edge for triggering the circuit.